Hello, dear lovely viewers. Good day to you all. You're welcome to today's class. I remain your tutor, Aisha Bande. So we have some questions to solve today, which is on the Graham's law of diffusion. So let's begin. The first question says that we should state the Graham's law of diffusion. So the Graham's law of diffusion is under, so this is under a topic which is called the gas laws. We have different types of laws which I've discussed in my previous classes, such as the Boyle's law, the Charles law, the general gas equation, the Avogadro's law. We also have what we call the general gas law. So today we are being asked for the Graham's law of diffusion, which is also one of the gas laws. So the Graham's law of diffusion states that as constant temperature and pressure, that the rate of diffusion is inversely proportional to the square root of its density. So mathematically we can write it that the rate of diffusion of a gas is inversely proportional, okay, to the square root of its density. So we can write, so mathematically, this is how you write. Mathematically, after stating the Graham's law, this is how you represent it, that the rate of diffusion of a gas at constant temperature and pressure is inversely proportional to the square root of its density. Okay, so that answers the first question. So let's move on to the second, which is the calculation part, and which is our bone of contention on this page. That's our interest. So the question says, if 280 centimeter cube of hydrogen diffuses in 40 seconds, how long will it take it for will it take for 490 centimeter cube of gas X, whose vapor density is 25, to diffuse under the same conditions, given that the relative molecular mass of hydrogen to be equals to 2. So this for us to solve this question, the first thing we need to do to simplify the question is for us to bring out the parameters. Bringing out the parameters makes the work easier for you, like it gives you a direction on what to do next. So it says that 280 centimeter cube, okay, of hydrogen, it diffuses in 40 seconds. So this 40 seconds here is the time, okay? So now the question is saying that the first question here is asking that, okay, the question is asking that how long will it take for 490 centimeter cube of gas X with vapor density 25 to also diffuse. So let's look for how many, if so now 80 centimeter cube of hydrogen will diffuse in 40 seconds. Let's first find out in how many seconds will 490 centimeter cube of gas X, that is a non-gas, diffuse, okay, the time. So let's call it X, okay. So from here, when we cross multiply, it makes the work easier, and this becomes 280 times X, which is gives 280 X is equals to, then we have 40 times 490. Okay, so here we have 280x is equals to, so here we have 40 times 490 gives us a value of 19600. Okay, from here we divide both sides, or we can say x is equals to 19600. We divide it by 280. Okay, and this gives us a value of 70. So x here is equals to 70 seconds. Okay, so moving on, phase, and we have the vapor density. So this vapor density is for gas X, okay? So we now say that gas X has a vapor density of what? Of 25, okay? Another value we are giving, or parameter given, is the relative molecular mass of hydrogen, not for gas X, okay? So the relative molecular mass of hydrogen is given as 2. So since we have the vapor density for gas X, but we do not have the vapor density for the hydrogen, so we have to look for the vapor density for hydrogen. So the vapor density for hydrogen, for us to get the vapor density for hydrogen is going to be equals to, the formula for vapor density is 1 over 2 times relative molecular mass. Okay, so from here we have that 1 over 2 times, now the relative molecular mass of hydrogen has been given as 2. So when we simplify this, 1 times 2 is 2, and 2 divided by 2 gives us 1. Okay, so now we have the vapor density for gas X to be 25, while the vapor density for hydrogen now is 1. So from here we can continue. We've gotten a direction to what we are looking for. Now, what we have to find is the time in which this gas X, okay, is going to diffuse. So we have a relation, or we have a formula under Graham's law of diffusion, which is that's when you're looking for the relationship between the time and the vapor density. We have a relation which says that T1 over T2 is equals to the square root of density 1 over density 2. So with this now we can find the value, we can find the unknown we are looking for. Question, we can see that the first gas that was given to us is hydrogen, right? So that means T1 here is, the one here stands for hydrogen, while the 2 here is going to represent the gas X, which is unknown. So T1 here is going to be time for hydrogen over T2, which is the time for gas X, is equal to the square root of vapor density 1, which is vapor density of hydrogen, over vapor density 2 is vapor density of gas X. So from here we can substitute in our values and get the answer. So the time for hydrogen is what we have gotten here. Okay, this 70 seconds. So this becomes 70 over the time for gas X, which is the unknown, is equals to the square root of vapor density of hydrogen is what we have gotten here to be 1. So we have 1 over the vapor density of gas X has been given as 25 from the question. So this is 25. So from here, for us to eliminate the square root sign, all we need to do is to take the square of both sides. So when we square both sides, the square root here, we cancel the square, okay? And this eliminates the square root. So here we are left with 70 square over t x square is equals to 1 over 25. So let's simplify here. 70 square, we're going to have 70 square times 25. That is when we cross multiply here this way. So we're going to have the value of 122,500 is equal to tx squared times 1 gives us the value of tx squared. So from here we take the square roots of both sides to get the value of tx. So the square root of the number we have there on the board is going to be, so we have the time for gas X to diffuse is going to be 350 seconds as the final answer. Okay. So viewers, if you have any question on the Graham's law of diffusion, kindly drop your question in the comment section and I will take it up from there. Okay. God bless you all. I remain your tutor, Aisha Bande. See you in my next class and bye for now.